Hello and welcome to Geometry with Mr. Clausen. Today we're going to get started on BPP 5, which is going to explore the idea of building codes. And this is just a short video to talk about the basics of building codes, at least in relation to this homework assignment that we're going to do. And so just to give you a really brief breakdown, this is the inspection record that we're going to use for this course. And in order to use an inspection record, we obviously need to know some basic things about building codes. And one of the things that we have on here is obviously, we have a place to write down the architect, the person that made a blueprint, the person inspecting it. And a lot of the little check boxes that I have here is a adapted form of an inspection record to show you the types of things I'm going to grade you on. So for example, are your mathematical measurements correct? Are the square footage and cost computed accurately? Is your drawing neat and tidy? Are lines looking parallel and perpendicular to each other as they should be? Is it legible? Tidy, centered, not crowded, writing is legible. Are door and window dimensions labeled, with that format that we talked about in BPP 3? Are your outlets and switches and fixtures and everything drawn correctly? And do you have labels? Are they correctly oriented? Are they spelled? And a big reason for all these little details is that whenever a contractor or anyone comes out to a job site, they want to know exactly what to do, where absolutely everything is. And failing to plan is planning to fail, is my opinion on this. And any contractor that you ever talk to, having a rock solid plan is an absolutely mandatory thing that is a part of any job. If you don't have those details in place, you're going to run into issues, and then you're going to have to modify, and the more that you have to modify, the more money that you're going to have to spend in the long run. So having a solid plan is something that you need to have. And part of that is just the architectural neatness. Part of it is the mathematical accuracy, in my opinion, as well, because you need to know how much things cost and how much of specific material that you need. And with that, you can get some decent estimates. But the other thing that you need is you need to know the building codes. And I'm going to briefly go over these building codes, and then I'm going to show you what I want you to do, at least in relation to the assignment. So I'm going to try to zoom in here a little bit. And so as far as building codes go, they need to be followed. And this is under the livability category that I'm going to put here. And there's a number of different reasons that these building codes are in place. Some of them, I think, are common sense. Some of them are just policies that are put in place by our government to protect citizens. And so if I know the clear reason for it, there is some reason stated there. And we'll go through each of these one by one and talk about basic examples of what each of those would look like. Because what I'm going to have you do after I talk about all these basic building codes and these criteria here is I'm going to have you look at the Plan A floor plan here and find as many of them as you possibly can. Because what happens whenever you want to build a house or add an addition is you got to make blueprints of all this stuff. But then once blueprints are made, those blueprints are shuttled out to a inspector, and they go look at it. And if you do not have a nice drawing, if you do not have your basic mathematical calculations done accurately, and you have building codes that are not followed, if you have any one of those issues, they will fail your house plans, and they won't give you a permit. They'll deny you your permit. And so the only way to pass an evaluation in terms of, let's say you send your plans to the city of Duluth, you have to pass all of these criteria to their liking, and they're usually pretty picky about it. I mean, they're just not going to let you go and build whatever you want. It needs to go through a fair amount of an inspection before they pass it and they give you that permit. So the details are really important here. And we'll talk about these little checkboxes at the bottom as well. But before we get started, I'm going to hit on the building codes. So one of the things that it says is that no bathrooms may open to the kitchen. Now, this is specifically for sanitary reasons. So, if we're looking at this and, you have a floor plan, let's look at our, think about like the apartment floor plan that we just got done with BPP 3. You had your kitchen, and you could say that the bathroom was really close, but there was a little bit of a hallway there. So the main definition here is, like, let's say you have your countertop like right here, and then there is a door right here that goes to a bathroom. So let's say this is like a galley kitchen, countertops on both sides, and this opens directly to a bathroom. This is not allowed based on standard building codes. You cannot do this in terms of the kitchen being directly accessible to the bathroom like that. There has to be a hallway or something that separates the two rooms together. And this is something that they will typically fail you on a floor plan because it's against building code. Exterior doors, this should be relatively simple to think about. They have to be at least 3 feet wide. Now, you could have said that the original apartment plan that we did in BPP 3 wasn't a violation because that was only a 2-foot 6-inch door. And then when we were going through, it's like, oh, I think I'm going to make it 3 feet. And a big reason for that is that it's handicap accessibility. Your exterior doors on your apartment or your house or any building need to be 3 feet wide to encourage this accessibility. And it's really nice for when you're moving as well. Okay, so make sure when you're using your architectural template that you're using the 3-foot variation on there when you're going through and drawing in those doors, or if you are assessing a house, make sure that those 36-inch 3-foot wide openings are being used. Now, as far as the house goes, there has to be at least 2 entrances to the house. This is just for your optional fire escapes. And your window cannot count as one of those 2 main entrances. Now, you can use a window if you need to, obviously. That might end up being a issue or a resource that you have to take advantage at some point. But in order for a permit to be passed on like a new construction, let's say, you have to have at least 2 entrances. So, if you just have your, house here, if you have a 3-foot wide door here, 3-foot 0-inch door here, and a 3-foot 0-inch door there, and then you have all of these other things, that would be fine. It can also go out into like a garage, and as long as the garage also has a 3-foot by 0-inch door on there, that would count as your second exit, at least in relation to this rubric. So also, interior doors should always be 2-foot 6 inches, 30 inches wide. Again, this is for accessibility. If you want like a 2-foot closet door, that is fine. But in general, all interior doors should fit this. So, if you have a door going into a bathroom or a bedroom, all those need to be 2-foot 6-inch doors. Now, one of the interesting things that sometimes pops up is that especially in small houses, this sometimes becomes an issue because they made bathrooms a lot smaller back in the day. My bathroom's one of those because I live in a really old house. It's like 113 years old, I think. I think it was like 1905 that my place was built, so 115. But anyway, so one of the things that has to be there is you have to have 2-foot 6 inches of clear space from side to side on the toilet. And we even see that on the one worksheet that we have here, is that toilets require a minimum space of 36 inches to be to code. That's what the minimum space allowed is indicating, but it's better to have 3 feet. That's the preferred amount of space that you have, but you need a minimum of 2-foot 6 inches, which is, this is 30 inches of space. And so, if you're looking at your bathroom again, the distance from the vanity to the tub has to be a minimum of 30 inches in order to be to code. So that's what that's referring to. Now, one thing that you have to have is you have to have those 2 entrances, like I was talking about, those 2 3-foot wide doors as fire escapes. But any bedroom that you have has to have a window that has a area of 12 square feet. So for example, a 3 foot by 4 foot window is a typical window used for a bedroom. Now it can be larger than that, but it has to have at least a 12 square foot window that can be used as a fire escape. And this, you might be thinking there's plenty of people that can fit in a 2 foot by 3 foot window, and that may be true for a lot of you. There's a lot of bigger people or obese people that would have a significantly harder time with that. And so 12 square feet is the general consensus for that dimension. It could technically be 2'6", and still technically be in that 12-foot category. That's kind of a weird shaped window. But, if it's 3 by 5 or 4 by 4 or something like that, those are also fine options because they're larger than the 12 square feet required for a window. So, again, I'm just pointing out a bunch of things to be looking for. And this only applies to bedrooms. So, like here you see, a bathroom with a 3 foot by 1 foot window. That does not apply to the situation because that window is not expected to be a fire escape, while this master bedroom has a 6 foot by 4 foot window. Well, that's 24 square feet, and that's more than adequate to use a fire escape. All living areas must have a window, so that that doesn't include bathrooms, halls, closets, and garages. Those aren't living areas, places where you have like beds and those type of things. So those don't have to have a window. And closets must be at least 2 feet from front to rear. Building codes state that a bedroom must be 7 feet by 10 feet or larger. Okay, and part of this is that if a room's being established as a living space, it has to have 70 square feet of space or more. Now you could argue that it could be 5 feet by 12 feet, or actually 14 feet, and still be within that. And I have seen some really weird, skinny, lanky bedrooms. Those aren't bedrooms. You can't just take a weird spot and just turn it into a bedroom. So that is it. The code says that it has to be at least 70 square feet. But my requirement is that if you're making a bedroom, 7 feet by 10 feet is the absolute smallest you can go. But if you want to go 9 by 10, 13 by 20, anything like that, those dimensions are all fine. But 7 by 10 is what you got to start with, and then you can make it bigger than that, obviously. And again, that's just to meet the 70 feet square requirement in terms of those rooms. And in practicality, I mean, if you're trying to make like 4 foot by 20 foot bedrooms, what are you going to fit in there? I mean, nothing's going to fit in there. That's, like a weird crawl space in an attic. All right, so just keep that in mind, that bedrooms have to be a certain dimension. No spot on an interior wall may be further than 6 feet from an electrical outlet, and any wall at least 2 feet in length needs an electrical outlet. Now, we've talked about this a little bit before. And again, the idea here is that, let's say you have a section of wall here. All right, and if we have an outlet here, I apologize, I don't have my template handy on me, so we're just going to talk about this real briefly. So, and we have an outlet here. Technically, what code says is that, no space on a wall can be further than 6 feet from an outlet. So let's say, you're standing here as a person, you're really happy to be here, okay? And so if you are 6 feet away from this outlet and 6 feet away from this outlet, then every spot along this wall is at least within an outlet by that distance of 6 feet. You could stand over here and you'd only be 3 feet from that outlet, but you'd be 9 feet from that outlet. But at least you'd be within 6 feet of one of the outlets. And so the general rule of thumb that I give you is that if you're not sure like where to place outlets, just place them every 12 feet apart from each other. Because if this whole distance is 12 feet, and then you have like, outlets spaced out that way, then you have plenty of options to plug your cords into and vacuum the floors or whatever you need to do in terms of that example. So, and that applies to any wall that's longer than 2 feet. So, if you have like a weird little crook in the wall or something like that, that's only like 18 inches, don't worry about it. You don't need to do those. if they are a wall. So for example, like on the apartment floor plan, another exception to that is like, let's say you have a door that opens this way like it did in the apartment plan going into that bedroom. If you guys remember, this wall was 2 feet in length for that closet, but you do not need an outlet here because it's behind a door. Okay, so that's also one of the exceptions allowed by that rule. But these other 3 walls, which for those BPP 3 projects that you did, all 3 of those walls should have had an outlet on them to be to code. So just some different examples and little things to kind of poke at and think about that. Now, no space along a countertop wall may be further than 2 feet from an electrical outlet. We talked about that a bit in the BPP 3 project as well. So if you have a kitchen here, and let's say again you have your sink and you have 3 feet of countertop here and 3 feet of countertop there, you could put an outlet in the middle of those 2 sections of countertop and you'd have plenty of coverage. All right, and again, the idea here is that most appliances, things like coffee pots, KitchenAid mixers, any of those type of things, most of those only come with 2 foot long cords, 24-inch long cords. So if you have an outlet every 4 feet, again, doubling that 2 foot length, just like we were doing to this situation, what that will allow you to do is then go and have access to all of your countertop space for your appliances. So again, you have an outlet here, an outlet here, and an outlet here, and as long as all those outlets are no more than 4 feet apart at a maximum, then you will be covered. Now here I skipped the sink. The sink is not considered countertop space, and generally you don't want outlets right next to the sink. Now you can get them protected with a GCFI circuit, and that just is designed to trip the outlet a little bit more quickly, so that if you get water in it and you have potential electrocution hazards occur, it will stop within, like, I think it's 0.005 milliseconds or something like that. It's a really short amount of time. Whereas if you didn't have a GCFI protected outlet, it would probably be, I want to say it's like 100 to 200 times longer amount of time, which if you're getting electrocuted is a fair amount of time, because what happens is that instead of tripping right out the outlet, that really short distance that it takes to get there, it has to be enough of an energy disturbance amperage wise to pop the 15, 20, or 30 amp breaker that's in your breaker box. All right, so not that we're talking a lot about GCFI and those type of things. We'll hit that a little bit in the electrical contractor module that we go through, but just know that as you're plopping that stuff in the kitchen, you have some 3 foot wide countertops on each side of your sink. Just place an outlet on each little part here while this is your sink. You don't need an outlet right on your sink, and again, as long as you're spacing them every 4 feet, you're going to be good, because you'll have, if you even want to put your coffee pot like right here, you're 2 feet from a outlet that way, 2 feet from an outlet that way, and you're going to have some flexibility. All right, so I know I'm going through a lot of things, and that's why for this particular assignment, once I go through these, all you're going to do is go through this blueprint, and you're just going to practice spotting some of these issues. All right, so building codes require there to be an overhead light in all rooms, including hallways, stairways, and porches. The living room is the only exception that is not part of these requirements. I don't really understand why. I think it's kind of a silly thing. I like having a light in my living room, but what a lot of homes will do is they'll have a switch that powers an outlet on and off, and then they'll hook lamps and stuff up to it. I don't really, it's kind of weird to me, but that's what the code says. So if you notice, like in this blueprint, if you notice that the living room does not have a light in it, actually you'll see that right here, there's no light here. That's not a building code violation. As long as there's a light with a switch connected to it everywhere else, you're good to go. Kitchen should have lights near the sink and the stove, and all overhead lights are required to have a switch, which should be located near the door to the room. All right, so just things to keep in consideration. So when you're going through these, this blueprint specifically for BPP 5, just look at each one of these codes and find as many issues as you can. I'm not saying that every single violation is taking place. This blueprint is riddled with issues. And in terms of the project, it's going to be a 15-point assessment. And there are some minor violations and there are some major violations. And what I will say is that you should catch the majority of the major violations. Things that are like super obvious, blatant red flags to these building codes. And there are a handful of the more minor, discrete ones. In general, if you get like 75% of both of those categories, you're going to get all the points for this. So if you miss one little thing, your grade isn't doomed. But, it's a little attention to detail. You got to go look for some of those things. A couple other things to check and watch for is, make sure there's no extra or dead-end hallways. Make sure traffic flow is reasonable. If it's like the labyrinth to like get to the bathroom, that technically is a situation that could be flagged and be denied a permit. You shouldn't have like this house where it's just like, a 3-hour long movie to get to the bathroom. I mean, it's kind of ridiculous. But anyway, and then rooms, doors, windows, closets, and counters are all the appropriate sizes. Okay, all those things should be, the standards based on, like the template or this worksheet that I just had over here, based on sizes that are on this page here. Interior doors, exterior doors. Do I have countertops on here? Might not have countertops on there, but countertops are typically 24 inches deep, 2 feet. So those are all the things that you would need to do. Now, when you're filling this inspection report, what you would typically do, and what I would typically do, is I would go get my blueprint, and I'll kind of start this. I don't want to give away anything because I don't want to take away like a super obvious thing. But this is the blueprint that you're going to be working with here. So I'm going to pull this up. So you should have this blueprint, and it's a 2-sheet blueprint. So it's Plan A and it says A sheet 2, and this will be stapled. And what you're going to do is, go ahead and just rip that off. And we have Plan Sheet A1. Go ahead and rip that off too. I'm going to take that staple. Set cabin 2 off to the side. That might be a handy one to keep around later. So this is a little bigger blueprint. And so what I encourage students to do when they're doing this is to go and lay this. And then what I do is I take one of these blueprints and I fold the edge. So I go and I'm just going to take a ruler and I'm just going to go fold. I'm going to fold the wrong way just to get started here. Make sure, oh, that didn't really fold in the right spot. So we'll do that part again. We'll just fold that. Make sure that folded in the right spot. All right, and now I'm going to go fold that the other way. Now, if you want to just fold the other way just to get started here. But generally, I go and I fold it so it's to the back like this, and I just adjust as needed. And get that all folded out. Now the reason I do this is I don't like working with these two pieces of paper separately. Okay. And then once I get that piece of paper folded, this should be to scale, and all I'm going to do is I'm going to match up the lines. And now you'll see here, I get all those lines nicely matched up. And now I'm going to get some handy dandy tape that I had from BPP 3. Oh, of course I just moved it a little bit. Me and my clumsy hands. Alright, and And now, oh, that was all the tape she had. All right. Boom. All right. So you get some tape on there, and now you have this whole thing as one super awesome blueprint, all right, that you have at your disposal here. Now for this project, you need to fill out this entire inspection record. I have both sides here. And so to get started, I'll tell you how to get started and go through some of the basics here with you as you're going through. The first thing that you need to do is, make sure you start with a clean one, obviously. But typically you go and write down who the architect is. Well, on every blueprint, it should have the architect's name on there. And this one's designed by Brad S. Fulton. So we're going to go and we're going to write down Brad S. Fulton. He's the architect of this blueprint, and I am Mr. Clausen. So you will put your name here in terms of the requirements. And now, he doesn't say what the square footage is, so I am actually going to have you calculate this because this is still a fairly early on skill. And what I'm going to have you do is I'm going to have you calculate the area of the home and the garage. So you'll have to use your knowledge of the area addition postulate and go and measure all that out. So, you can go and do these in different squares. All right. And I mean, what I would do in this situation is you can actually do this in large swaths. Okay. So for example, I can go measure this and I can tell you that the distance from here to here is 5 11/16. All right, include the walls as well. And then if I draw myself like a little divider line here, what I would typically do in a situation like this is I would actually draw out all the little different squares and rectangles. And I'll do the first one here just so you can see what this would look like. Okay, don't include the porches and stuff. Oh, sorry, just move that over a little bit. And again, it's just applied area addition postulate that we're utilizing here. Oh. And so, you go, and all I'm trying to do, again, is just draw out all these, individual squares. Move this just a little bit. All right, and so you can see that there's a big square here. You see a medium square there, a little square there, and then we'll have one more square here. And those, when you add all those together, that will constitute the area of the home. Okay, and this is something you should know how to do. Now, when you're looking at this, the width of this square is 5 11/16 of an inch, and the height here is 6 3/8 of an inch. Now we need to convert that to scale. So remember, 6 times 4, that would be 24, 25. So this is going to be equal 25 1/2 feet. That's going to be the scaled height here. 5 times 4 is 20. Now this is almost 3/4. So that's 2/4 plus 3/16. So this will be 22 3/4 feet is the scaled variation of that. So I've given you a little extra practice there. And you'll notice that there's some built-in repetition with this assignment because I want you to get some experience with that. So the area of this big square right here is simply can be determined. And so if we take the area of this, this will equal 580.125 feet square. And this is just found by taking the product of 22 3/4 feet times 25 1/2 feet. And so that would be the area of just this square. So what you're going to do in terms of figuring out the square footage is, do this square and then add that square to it, add the square down here for the closet, and then add this square over here for all this living area. And you can include the water heater if you wish, since that will be part of that. And then what you're going to do is, once you figure out that calculation, you're going to put it here. All right. And so, you'll say 1,000, something, most likely. And then to figure out the total cost of construction, what you're going to do is you're going to take that area and then you're going to multiply it by the median cost per square foot. And the value that you're going to use for that is what we found in BPP4. You're going to use this 166.22. Now, if you got a different value and you want to use that one, that's fine as well. Just make sure I know that you're basing that off of yours. But if you copied mine, you'll just use that value. That's your median cost. And then what you'll do is you'll multiply that area by that cost to get your new cost of your construction. In the garage, you'll also take the square footage of the garage. So take that last area here, include the walls, like the whole pad space. Make sure not to double count any space, but measure the area of the garage. So that'll be some 3-digit number. Find the area of the garage. Now, the cost per square foot for the garage will, as a general rule, be half the square footage cost of the house. And the thought with that is you're not putting as much money in flooring and wall materials and those type of things. So the garage will be $83.11 per square foot, and you'll take whatever number that is and multiply it by that. And again, this is just a tool based on the median cost of homes for a given area to go out and assess, like, what is the relative value of this home once it's built. And that's really handy for the government, because then they know how much to tax you for that property once you've built it. All right, that's probably one of the most important pieces of information that they want on that. And so now they want you to obey the law too. Don't misconstrue that statement too elaborately. And so you can go and calculate those things out, and allows you to do that. And so now, once you have those, we're going to say that your measurements are correct. We're going to say that you computed it accurately, and I will double check that work. Is it nice and tidy? Yes. Are the lines parallel and perpendicular? Are all the door dimensions and everything included? Are lights and, fixtures drawn correctly? Are they labeled? All those things look really good. And so now I will just tell you, for the sake of this assignment, that you will fail this permit. Okay, I'm just going to tell you that right now. There are issues in this blueprint. There's a huge swath of them. And so what you will do is carefully read over all of these and see what you can find. Find as many of them as you can. If you miss one or two, you're still going to get all 15 points for this particular assignment. But 3 points will be based on doing all your square footage calculations correctly, and 12 points will be based on finding enough of the major and minor building code violations. And just so you're aware, for the square footage calculation, you are always given plus or minus 5% error on these calculations, because this is a relatively new skill that we're working on. So what that means, just as an example, is that if the area of this house was 100 square feet, 5% of 1,000 square feet would equal 50 square feet. So you would get 1,000 square feet plus or minus that 50 square feet. So as long as your calculation in the end is between 950 and 1,050, like if 1,000 square feet was the exact value, then you would be just fine in your calculation. You're given a little bit of error. So, you know, if you're worried about like, oh, should I have not included that wall? Should I have included that wall? And those type of things, and you're kind of navigating that, you don't have to get that meticulous about it. But that, I figure if I give you plus or minus 5%, then that gives you that 1/16 of an inch tolerance that we've talked about in the past. It actually probably gives you a little bit more than that. But with that said, I'm going to turn you loose. So this is your homework assignment, is to scour this blueprint and find as many of these errors that are present in the blueprint as possible. And what I would like you to do is, as you're going through, you know, if we were to say like you were supposed to have a light in the living area, you know, put a note like right in the blueprint and say, you can say just building code violation or something like that, and say building code violation, and actually tell me what's wrong. Draw an arrow to it. You know, maybe you look here and like, oh, this is 14 feet here, violation. You know, actually state what the violation is and identify it there. I got to know that you actually identified it. So make sure there's a note there clearly indicating that you found an issue with a particular location. So with that said, I hope that you got a better understanding of some of the basic building codes that we're going to look at in this course, and that you have an idea of what to do with this building plan A floor plan, how to calculate it, the sum of the square footage, and some of these other variations. And with that said, let's do some math.